The broadcast is now starting. All attendees are in listen-only mode.
All right, good evening, everybody. Welcome to vBrownBag. Today we are going to look at Azure VM fundamentals with Paul Cradduck. A little bit of housekeeping here. We've got numerous vBrownBag shows available many nights a week. You can also reach us at all the various vBrownBag Twitter handles. Tonight we'll be watching for questions on Twitter using the vBrownBag hashtag, as well as tweeted at the vBrownBag Twitter account and here in the chat box. I'm your host, Paul Woodward Jr. On the line we have Tom Green as well as a co-host. And without further ado, we will hand off to our guest speaker, Paul.
Great. Hey everyone. All right, so let's jump right in here. I assume everyone can hear me pretty well, and we'll just get started. So this is going to be a vBrownBag talk on Azure VM basics. So little quick agenda here. We're going to be doing some introductions. Hit the Azure air quotes basics. There's not a lot that's basic around Azure. There is and there isn't. So it'll be hopefully a good talk. We'll talk about the Azure Marketplace, some differences between on-prem and Azure. We'll hit some demo. So we'll actually do some live portal stuff. Talk about some ARM templates, what those are, what you use them for, and then a little Terraform demo. And then we'll hit some QA and wrap it up. So hopefully it's worth everyone's time here. Bit about myself. Paul Cradduck. I'm a senior cloud and DevOps architect at Round Tower. I am often found on Twitter, so if you any questions, I know that a lot of times these are recordings, so just hit me up at pcraddock there on the screen. I also blog at virtualtraditions.com, so feel free to check it out. It's not super, there's not a ton there, but we're getting there. I'm a VCDX on data center. A Google certified cloud architect, and I just recently completed my MCSE for Azure Cloud Platform. So I've kind of made a jump from the VMware world, haven't left it, just evolved. So still very involved within the VMware circle, and now pressing into cloud and the three major public clouds. And there's no AWS certs on there yet, but I guess now that I'm saying this in a live session, I guess I have to get on that. So we'll see as that goes. So awesome. First thing is please ask questions. Don't make me talk for 45 minutes straight. I will, but I think it's really good if it can be interactive. And I know even if this is a recording, please hit me up on Twitter. I would love to chat. Definitely take some time, to actually talk in person or over the internet if that works. So please keep the questions coming. So let's jump right in here. First things first. I do my own slide decks, and spell checking is a team sport. I'm sure I misspelled something. You're probably going to find it as you watch, and that's okay. I got into computers because they spell check for me for the most part. All right, so Azure, the basics. So on the right here, we've got some constructs in Azure that we don't see on-prem. So, and that's mostly going to be the focus of my talk tonight, is kind of the differences of what a VMware guy had to learn as he started his journey into Azure and what it meant. So, first things first, on this outer layer, we have Azure, and we have an Azure subscription. Now, you can think of a subscription as basically where the costs go, right? So there's a credit card behind that, there's an ELA behind that, there's something behind that, right? And so the subscription basically catches all the cost and directs where you want that to go to, right? Within that, we have this next box here and that is a resource group. Now, resource groups are basically this virtual construct. They contain everything. There's a bunch of different ways to break them up, but they can contain everything for an application, everything for specific VM. You can break those out into just containing your storage accounts, just containing your networks, just containing different things. We'll get into all that probably later, but let's just for now just know that a resource group is just a way to group logical related items. Probably the easiest way to think about that. Down from that, we have on the right, we have, or bottom right here, we've got storage accounts. Now, storage accounts, they basically contain all of your information. They're a lot more than just that, but in our example here, for just Azure Basics and just VMs, that's where my virtual hard drives live. That's where my VHDs live. There are other more native things that can live in there, right? So we can have things like native just blob storage. We don't have to have a VHD. We can have tables, which are like SQL-Lite, Excel on steroids kind of thing, with queues. We can all kinds of things in storage accounts. All of that is probably outside the realm of what we're going to talk about tonight, unless someone asks a specific question. But for purpose of tonight, just think about that's where I stick my hard drives. So this is our in VMware. This is our data store. It's a lot more than that, but easy way to consume that. Outside of that, at the bottom here, we've got virtual network. Now, this is a construct that took me a second to get. A virtual network is not a subnet. For our networking guys or gals that are listening, it probably makes more sense if you've lived more in the route switch world where you had to define these giant subnet ranges or these giant IP ranges. For me as a VMware guy, I never had to worry about that, right? I always thought in subnet VLAN terminology, and there are those in Azure, but this is not that. This is going in and defining this massive block of IP addresses, and then out of that massive block of IPs, I can then cut up my subnets or my VLANs. Now, there are no concept of VLANs normally like we would think about them, but think about them as subnets, right? And so that's our next thing, and that's up just a little bit. So in my example here, I've got a 10.16.00/16. It's a massive subnet. It contains, I think, /16 is like 65,000 addresses. One of the subsets of that is that 10.16.0.1, and that's that /24, which is 254 addresses. Now, this is not for a test or anything, but Azure does consume 5 of those addresses by default. So your gateway and a few other addresses are reserved, so you cannot use them. But that's, you'll see that as you cut these up. Within, we'll jump up a little bit in this diagram here. Within the virtual network or subnet is this concept called an NSG or network security group. And think about this as your firewall, as your external firewall. Now, it's in some ways it's more basic than a firewall. You're not going to do things like application layer, packet inspection, or those things. It's kind of basic. It's more of a port in, port out. Can talk to this IP range, can't, those kind of things. But the cool part about this is NSGs can be assigned to entire subnets or just all the way down to the individual NIC that is on an Azure VM. So that's kind of cool because as a VMware guy, I knew micro firewalling from the NSX days, right? We're in the NSX days. I knew that from NSX, right? This idea of micro-segmentation and taking firewall rules all the way down to the VNIC. And that's what an NSG is. Also, you can also take that same construct and slap it on a subnet as well. So it's really powerful in some of that microseg environment. So it's really cool. A network interface card. Now, I call that out separately. I think a lot of us probably know what a NIC is, but why I call that out specifically is because in the VMware world, when you destroy a VM, the NIC goes away, right? By default, the disks go away too, but the NIC definitely. We never think about spinning up a NIC and keeping it around if it's not attached to a VM. But in Azure, that idea is actually how it works. You can spin up a NIC completely separate of its machine and have it there. You can spin up when you destroy a machine, if you don't destroy the NIC, it's still there and still has an IP address assigned to it. And so we think that is a huge shift for us from a way to think, because these NICs can be, it buys us some dynamic things actually. So maybe I can talk about that a little more later, but it's just something to be aware of, that the NIC is a different construct than the VM itself. Virtual machine, I think we're hopefully all pretty familiar with what that is, but it's just a collection of disks, files, some compute, some memory, some hard, I already said disk, and then a network interface card and an operating system, right? Some data, some applications, but it's a server, right? So it's pretty much the same. If you're a VM guy, it's a VM. If you're a Hyper-V guy, it's still a virtual machine, but probably Hyper-V. If you're used to that, it's a little closer to what it actually is in reality. And then we have this concept, and this is probably as deep as I'm going to get into this topic for tonight's conversation, but maybe in another cast later. Availability sets. So this is something that's interesting. As a VMware guy making the transition to Azure, I thought, great, I've got my VM spun up, I'm communicating, I've got everything I need, and if my Hyper-V host, for lack of a better term, in Azure goes down, well, my machine, if it goes down for maintenance, they'll just vMotion it over, and that is not true. Your machine does not vMotion. It's way too expensive from a network cost. Azure's too huge, too big. The scale is too large. So they actually don't do things like vMotion. So if if the host goes down or you reboot it for maintenance, your VM is going to restart. And so you have to, as engineers and architects in our field, especially when we start to look into the cloud providers, in this case Azure, but this is true of others. You need to be aware that there is no vMotion to save your VM, and so we have to use things called availability sets, and we'll talk deeper about that in a few slides to keep your application alive, right? Your VM not staying alive, but your application could if architected correctly. So before I jump out, I just talked about a lot. Any questions from anyone?
We've got nothing in chat as it stands, and looks like nothing on Twitter yet.
Okay, no worries. We'll jump on here. So the Azure Marketplace. Think about this as the App Store of Azure, right? And we have AWS has a similar construct. We have GCP or Google Cloud Platform has a similar construct. But these are all your pre-baked, pre-canned solutions, right? So if I need a VM, I can just go out and open up the marketplace, type in the OS I want, and there's a wide number of VMs I can just click and deploy. There's a wide number of both Linux and Windows flavors out there. There are, and every construct within Azure can be deployed from here, all the way from on the screen here. We've got things like NSGs and load balancers, which we'll get into a little bit later tonight, all the way down to SQL and these other platforms called web apps and like there's WordPress down here, and there's all these other things, Azure Automation. There's all these constructs, and so this is from a GUI perspective how you can kind of air quotes shop the Azure Marketplace and spin up what you want. So pretty straightforward, not a ton to say there, but if you're new to Azure, it's a good place to go and just click around, see what they offer, play with some of the stuff that they offer. And if for a lot of it, like if you want to just play with Splunk, for example, you can just go deploy Splunk and just start playing with it. The licensing, all that's kind of built in. So depending on how much you want to pay for that learning, you may or may not have to, just mileage may vary on cost. So just be aware of some of that. But it's really great if there's something specific you just want to spin up real quick and test. So I already talked about this a little bit, this idea that the network interface card is separate. So like I showed here, this is actually me spinning up just a NIC just separate of my virtual machine, right? I've got new NIC, I've got to attach to that virtual network, I've got to attach to this subnet. I can give it a private IP address, either dynamic or static. So static, just like it works on-prem, dynamic DHCP, just like it works. I can either then create security groups here or use pre-existing security groups. I give it a subscription, which we talked about, a resource group, which we talked about, and then a specific location, and there we go. So, but like I said, completely separate, and then it can be attached and moved around to different machines. So something to be aware of. Also be aware that things like load balancers, they think about load balancing at the network layer, not specifically the VM layer. It is involved, but you're going to target a NIC, not necessarily specifically a machine. You'll pull it in eventually, but you know, it's just an extra layer that I don't think we all always think about as maybe on-prem people. A couple other things. Azure VM sizes. Now, this was definitely different for me, going from a on-prem VMware guy to the cloud. I couldn't just select that I wanted 1 core and 64 gigs of RAM, you know, with a 4 terabyte disk. I actually was locked into specific sizes of machines and matching things that I may or may not have wanted. So there's a couple different types in Azure, and I've got the link here in the deck. So if we send the deck out later, you guys can have this. But first we have general purpose. So these are, you know, as it says right there, these are balanced, good CPU to memory ratio, and there are the different sizes there. Compute optimized, these are higher core counts, a little bit less memory on those. Memory optimized are the opposite, right? Higher memory, less core, and storage optimized are more, you get more IOPS out of the machine, maybe less memory, less CPU, but just higher IO. GPU, so that one's, I think, pretty straightforward. These ones have GPUs, these sizes have GPUs built into them, into the SKUs. And then higher performance compute, you know, more powerful CPUs, and you know, and those kind of things, higher throughput on the NIC cards, so you can kind of read all that. So that's just something to be aware of when you're building out and architecting an application, that you may end up in some of these buckets that that weren't previously constraints. And we'll see that as we continue on here a little bit. So as I was saying, we're talking about Azure VM sizes and optimizing for either CPU, memory, or IOPS. And this might be a little small when we get into the demos, and actually, you know, I'll hopefully this will be a little bit bigger here, but you can kind of see over here on the right that we've got some family, like we talked about, general purpose, memory optimized, compute optimized. And across, actually, Azure recently updated their UI to make this a grid. This used to be blocks, block pictures that you could select, and that was a little bit more challenging to really find the machine you wanted. But now they've iterated and have done a pretty good job at making this a little easier to search. Now you can add stuff. I'm current because I'm selecting a specific type of VM I want, and then we haven't talked about disks yet, but premium disk, and you know, so I want premium disk here, and so I can filter based on all these, and then I can see things like 1 CPU, 2 gig of RAM, 2 data disks, max IOPS, you know, premium disk, and how much it's going to cost, estimate per month. So let's talk about a couple of these line items here. Max IOPS, that doesn't necessarily mean that these 2 data disks are going to give you 16,000 IOPS. It just means that no matter how many disks you attach to this machine here, that it's going to max out at 1,600 IOPS. And so that's, you know, all the way down through the line, you can kind of see where that goes. And then we have this weird column here, temporary storage. So what that is that is a temporary, at least on that first one, 4 gig, some 8 gig, some 16, they're different sizes, but those are actual local SSD storage that you can take advantage of, local to the Azure host that you're on. So, you know, the Hyper-V host essentially underneath has a local SSD, and you get a temporary disk that sits directly on that. It's very performant, and it is very temporary. If your machine moves, you lose everything on it. If it restarts, you lose everything on it. It's a great place for page files. It's a good place for applications that just need some quick IOPS, but don't care if the data gets lost. So, you know, so if you got something out like in a cloud storage somewhere, you want to pull it locally, you need some quick space, you know, some quick IO on it, put it there, and then pull it back down if it gets destroyed, those kind of things. So in general, you definitely do not want to set any persistent data on those. And other than, page files and some real quick stuff, you're not going to want to put a whole lot there, but just be aware that it's there and there are some use cases out there. And yep, and then over here, like I said, we've got our pricing. So this model does force us to architect a little bit different, and architects and engineers to really get the application, spin these up with the application in mind, and really forces us to get it right. Where as before, maybe we would just throw more CPUs at it, even if it didn't need it, those kind of things. That's really not a good idea here, and so we'll get into some more of that a little later. So to my point earlier here, so let's say you needed 128 gigs of RAM. So you go into the portal, you select your machine, you tell it 128, and all of a sudden you're locked into these machine types that are fairly expensive, and yeah, it's 128 gigs of RAM, so yeah, it's going to be a little expensive, but the lowest I can go is 4 cores. What if I just needed 2 cores? You're not gonna be able to do that, right? And in fact, there's only one machine type that gets you 128 gigs of memory at 4 CPUs. So if you needed something else, you might get forced to use one resource over another. So that again just kind of drives the point home for me as I was getting into this, as building applications, to really make sure that you're actually going to utilize 128 gigs of RAM before you spin up a machine. Because while this particular example, 4 cores, that's maybe not too oversubscribed, but the inverse also works. If I needed, say, 32 cores, I'm stuck with more memory a lot, sometimes than I'm really going to need. So, it's just worth another way. It's just worth thinking maybe a little differently about scaling out versus scaling up, especially when we start to look at some of these prices, right? And like I was talking about earlier, with these, as the machines go up, you can see that the temporary storage available to these machines also increases, clearly, because your page file is going to be larger. So it's pretty straightforward. So let's jump into a little bit of one of the deeper topics I think that people may not know about as much, and that is this idea of Azure machine extensions. So I've got a couple here on the slide, and then I've got a link to a full doc for all of them. Azure machine extensions are software packages that can be injected directly into your VM from outside the machine. So you can actually push things like Chef or Puppet directly into the machine without ever logging in while you're spinning it up. And that is really, really powerful, especially from a configuration and a desired state perspective. So we'll click in around a little bit in that and show you in the portal once I get more to the demo here. But there's a ton of them, so they're worth looking at, right? If you use Acronis, if you use Datadog, that can be really great. There's also PowerShell desired state configuration, or DSC. Azure's DSC, think Chef or Puppet, so it's desired state, but built directly into Azure, and is very similar to like a Chef, where you write code for what you want the state to be. If it's not, it'd be, DSC comes in and makes it true. If it is true, it changes nothing, right? So it's that idea that if it needs to be changed, it will. If it doesn't, it won't. So things like, I want to always make sure that my RDP ports are open. I always want to make sure SSH is turned on, if it's Linux, those kind of things, right? So that can be really good. And you can push that all through extensions, write one DSC script or one Chef script or one Puppet script, and roll it out. And so that's really nice, less infrastructure to set up. So let's be done with me chatting, and let's actually run through a demo here of the actual portal here. So let me hop over into Azure, Can you guys see my screen from Azure?
Yes, sir, I am seeing it.
Great. So this is Azure's portal, and I'm logged in here, and I spun up this this resource group and this VM just to kind of play through tonight, because I think slide decks are great, but the portals and actually doing some of the stuff is, I think, more worth it. So we've got our always free vBrownBag. Always free because, and we'll talk about this a little later as well, there are subsets of resources here that that are always free. So if you want to start playing with Azure, a great place to start is spin yourself up a subscription. They'll give you, I think, as of the last time I checked, which wasn't too long ago, it was like $300 of free credit, and then you've got all these free services here. So a Windows machine for 750 hours, Linux machine 750 hours, 128 gigs of Azure managed disk. We haven't talked about managed versus unmanaged yet. I'll get into that. Table storage, all this other stuff. 15 gigs outbound, and these other services here that we're not going to get into tonight. But you can play with a bunch of this stuff at no cost, which is really, really great when you're trying to learn it. You can actually spin it up and not hit the bank too hard. You may if you want to play with some more advanced stuff, you may have to spend a few bucks, but the $300 in credit is really helpful to to play with. So that's what I did for the vBrownBag here tonight. I spun up a free resource here in the Windows machine and just wanted us to kind of click around and be able to play with this. So let's jump back in here. And as I said here, my resource group contains everything, right? Everything for this machine, for my Windows VM. I've got my VNet, I've got my subnet within here, I've got my NSG, I've got my public IP address for my Windows machine, I've got my disk, and I've got my network card. And so you can see here that we also have locations. Azure, actually on the dashboard, I don't know if I have it real quick. Health services. Yeah. Well, can't really see it too well there, but there are Azure data centers all over, right? So we've got, as we spin up new resources, actually let's just go ahead and just show you real quick, right? So if I want to make a new virtual network, create it here, and then it's down here, it's going to ask me where I want to go. And so I've got all these different places to go here, right? I've got East US 2, US Central, West, Korea, Canada, Australia, India, all over. They're global. So maybe not as big as AWS, but pretty darn close, right? And so that's pretty that's pretty incredible that I can spin up resources halfway across the globe with just the click of a few buttons here. So let's see. So let's go ahead and run through, like I said earlier, an actual machine build here. So and let's go back to that all services free, and let's do a Linux one this time. Okay, so we're going to create a new resource group, call it free Linux, doesn't really matter. This is my subscription. That's yours will look different depending on what you spin it up as. Okay, Linux VM, US East, and then these are all of our operating systems that we can choose from, all the way from 2012, 2008 R2 to 2016, Rail, Ubuntu, CentOS, a decent number. These are all pre-baked for me. I don't have to configure these. I don't have to patch them. I have to patch them after I spin them up, but the base images, they keep on ahead of. So cool. I haven't played with 1710 too much. Let's go with that. And I'll probably stick with, this is a free offering, so one CPU, 1 gig of RAM, 2 data disks. That's all they're going to do for the free. Now it's still going to say it's $7 a month, but they dropped that off because of because it's I forget where the exact line was, but it's small enough that they just rounded off for the free version here. So we'll select that again. For this, we're going to go password. Throw in a username and password here. Great. We're not going to do Azure Active Directory. And for the purposes of this talk, I'm not necessarily going to get into it, but think AD on Azure with a lot of caveats and a lot of different things. So great. Now we need to actually be able to communicate with our VM. Our VMs, unlike on the on-prem days, we don't have console access. So if you want to talk to this thing, you're going to want to have the RDP port open. And so we're going to go ahead and do that. And the next, and we can tag it. We'll get into tagging. Well, actually, I won't necessarily get into tagging in this chat, but tags are great ways to organize resources and bill back, charge back, those kind of things. So let's go ahead and review and create. So great. That wasn't so fascinating. I think we all probably expected that it would work, and but as that goes on, we'll continue on. So a couple of the things to talk about while we're in here, though. This is the view of my machine. Now, again, if you're a VMware person or just on-prem in general, and you're not used to cloud yet, this is a lot of information, man. I remember the days when I first saw vCenter and thought, wow, this is a good amount of info. This really is an amazing amount of information, right? I've had this machine up for a little bit. I think I spun it up earlier this afternoon, and so we can go out, 6, 12, all the way up to 30 days and see. And this is just basic information, right? So it's great from a logging perspective. My networks, like I was talking about before here, we've got our NSGs. So I've allowed RDP in from anywhere. So this VM, which will be destroyed after this recording, but has a public IP address and it's on the internet. So if you wanted to try to RDP to it, go for it. It'll be up for another few hours. And it's allowed to talk to this particular VM. And these rules here, as you're seeing inbound and outbound, these are base rules. They're applied pretty much to the NSGs by default. They allow it to talk from any virtual network to any virtual network within Azure, to load balancers, and then ultimately there's a deny all rule at the bottom. So deny inbound and outbound if it doesn't meet certain criteria, right? So a lot of security first mind here, because if I hadn't popped RDP open, it literally would be cut off from the world. So security first is there. And again, this idea of NICs can be detached and attached to machines separately. So if I wanted to change IP addresses, I could just pop the NIC. Disks. So let's talk real quick about managed versus unmanaged. So I don't know if you remember my my slide in the beginning where I had VHDs. I had some in a box pointing towards a storage account and some just out on their own. So managed disks are where Azure's moving, kind of now going forward. In the past, you had unmanaged disks, and those disks had to sit in storage accounts, and those storage accounts had limitations. You had things like, and you still have these, like 20,000 IOP maximums per storage account. So you had to think about things in a granular level. If you needed more IOPS, you had to spread your disks across different storage accounts, those kind of things. If you needed to replicate them, they had different implications. So now we've got this idea of managed disks, and Azure takes care of a lot of this stuff for me. With managed disks, I actually see the disk in my resource pool. I see it, I can click directly on it. I can, see things like this here where I see that it's premium SSD. I don't have to think, I've got read-write caching here. I don't have to think about how the storage behind, did I pick the correct type of blob to put my disks in, those kind of things, right? We had to think about those with unmanaged disks. With managed disks, I don't. And there's some replication going on in the background without even, we haven't gotten to availability sets, but without even doing anything, I've got backups of these of these disks. Now I can't get to them. They protect me if Azure has an issue, but I've got multiple backups because Azure's guaranteeing it because there's SLAs behind them. So that's kind of nice. Sizing. Let's talk about that real quick. If you wanted to change, so I spun up this machine as a free VM, 1 CPU, 1 gig of RAM. If I do a bunch of work on this and decide, I want to take this out of the free tier and I need some real horsepower on this thing right now. All I have to do is select the computer type I want, 2x8, some extra data disks, and hit select. Now that machine's going to reboot, but when it comes back up, it's going to be a new machine, right? It's going to be the same OS, same data, all of your data is there, but basically it gets attached to a different shell machine that's going to have two vCPUs and 8 gigs of RAM. And so sizing up and down is as easy as just selecting the different sizing types that you need. So that's kind of nice too. Let's not size that. We'll hit extensions and availability sets, and then we'll see if there's any questions here. So extensions, like I mentioned before, are right here in the portal. So if I wanted to go ahead and use Chef, for example, in one of my Windows VMs, all I have to do is hit create on this Chef extension and point it at my Chef server, hit the drop my Chef URL in there, give it a Chef node name, give it the cookbook that I want to run right here. Client names, I need to give it the SSH key or the cert keys and everything, any environment variables, and just hit OK. And all of a sudden, the machine, after a couple minutes, while it pushes the agent in and gets that spun up and registered, it pops up and Chef configures it and it runs. And I didn't have to do anything. I'd have to log in to do that. That's really awesome. I can do that to machines that are already spun up, or I can do that at time of creation. So there's some really cool stuff to play with out here in this. I think I have a slide deck. Yeah, I have a slide on availability sets. So let me go back to my slide deck real quick. Actually, before I do, any questions?
The only question that's popped up thus far is, what was the username and password again?
Excellent.
Oh wait, what do we got
actually
here?
did just do one. Yeah.
What is in background to support Azure Cloud? So I'm guessing that means, like, what is it running on?
Yeah, possible. Yeah, if I understand, yeah, if I mention that question, yeah, what's it running on? I don't 100% know. I would. It's probably some Hyper-V on steroids, and probably running some Windows Core stuff. I don't 100% know. I've actually never gotten the privilege of seeing Azure's backend. I do know some people that work there, but haven't gotten that deep into the platform yet. So, and you don't actually see it. So I'm not 100% sure on the exact hypervisor that's running. And the exact machines are tough. I know that when I spin up VMs, that they're Intel CPUs underneath, and those are different based on different regions. But other than that, yeah, I'm not 100% sure. Don't know if that answers the question or not.
Oh, we got one more here. Let me expand the chat box out. Is it the, let's see, is the same tech to support containers as well?
Yeah, so containers, if you mean containers as in there's a couple of different things you can do with containers within Azure. There's a native platform as a service offering, AKS, so that's Kubernetes directly on Azure, that you just bring your container and plug and play. There is that runs on a, and so this is infrastructure as a service VM. So these are, I have to patch the Windows, I have to run the application, I have to do all that. Whereas platform as a service is more, if we're talking about Kubernetes, they're doing all the setup, they're maintaining it, those kind of things. If you're talking about actually running like Docker, you can do that. There's a couple different ways to do that. One way would be to spin up an infrastructure, as a service VM, so just a regular Linux, or I guess Windows if you really wanted to, VM, and then install Docker on it. I don't know if that fully answers the question.
And that looks to be the end of our questions for the time being.
Okay. Yeah, so maybe we can circle back if there's some more clarification on that. Great. So let's talk about availability sets real quick. There's a concept that, like I said, your machines are going down if a host goes down. So In this example, I've got 30 web servers. Now, these are really beefy web servers for anyone that goes and looks at what a DS15 v2 is. They're huge. This is actually designed a Splunk implementation that ran on Azure, and these were the indexers, so they're massive. But this is one of the ways we had to break it out to make sure that the index cluster never went down. So we have 30 machines, and the way this was architected was 3 fault domains. So vertically, think about these as racks. Think about these as 3 racks in a data center sitting next to each other. They're probably not sitting next to each other, and they may not even be in the same physical data center, but they're 3 different racks. And then think about these horizontal boxes as don't think about them. They are update domains. Think about these as I'm patching the 3 Azure physical hosts in the bottom of this rack. So 1 host here, 1 host here, 1 host here, and each of those hosts has 2 VMs on it. So what this does, it allows me to, and there's SLAs around this, but it allows me to lose this rack. So rack 0 goes out because the top of rack switch dies, or 2 top of rack switches die. This whole rack goes away. But these 2 racks are up and running, and 20 of my clusters, web servers in this example, 20 of my web servers still up, so my website's still up and serving data. And then, there's an SLA around getting that rack back up and those kind of things. So, more to dig into if you're really architecting these, but that's something to be aware of there. Now, update domains span racks. So what you're basically telling Azure is that anything in update domain 0 can be patched at the same time. So this host, and this host are all going to go down, and before this one comes back up, this one can be patched, and this one. So I'm going to lose 6 of my VMs to the host patching. Now, keep in mind that your VMs aren't down the entire time that host is being patched. It's very likely that machine is coming back up on another host in the rack, or at least another host within this fault domain, and it's probably only going to be down for a few seconds as it comes back up. And there is actually some technology in there that allows, think about it if you're a VM person, think about it like fault tolerance, where you're consistently cloning the memory in perfect sync, like that constant vMotion. There's some of that can go on the back end. So sometimes they patch and you don't even know they did it because they were able to just clone the VM in such a way that it just fails instantly over to the other host. But that's not guaranteed, and it's not guaranteed that they're going to do that either. So there's some documentation to be looked at there. But when I patch, it basically says, patch everything in here and don't move on into this update domain until this update domain finishes. Now, there's a double-edged sword here, because what it means that your application better be able to start itself without a human interacting as just the machine comes up. So my web servers here better come up, and IIS better run correctly, or whatever. Actually, don't state these are Windows. Apache better come up, and so things like Puppet, Chef, DSC, those become really, really, really critical, because I don't know when this is going to get patched, and I don't know if it's going to come back up after a reboot. And so I need, not only do I need to make sure I'm testing that, but I really need to make sure that some sort of desired state configuration tool is backing it to make sure that if IIS didn't start right, it keeps getting kicked until it does, and then I get alerted if it doesn't, and those kind of things. Because Azure will make sure the VMs are back up before it rolls on, but it's not going to guarantee that the web server's running. So just something to be aware of. This, however, is a very expensive way to architect high availability. There's a lot of machines in here, and for true, I forget the exact number now. Something like 10 machines have to be spun up to guarantee like 5 nines of availability. Don't quote me on that exact 9, but like it's expensive to guarantee specific amounts of uptime. And so because of that, Azure recently announced not that long ago that they are moving away from availability sets and going to availability zones. So that greatly reduces the number of machines you need. You're going to be split across different data centers, and and the architecture changes. Availability zones are not compatible with availability sets. So machines today that are in an availability set cannot just be converted automatically. You have to do some work to rebuild those into availability zones. But just be aware that that's where it's moving, and it's a really good move for them. So let's hop out real quick back to this portal. And so as you can see here, this is my one Windows free VM again. I don't have an availability set, I don't have a current fault domain, and I don't have a current update domain. But if when I built this machine, I spun up an availability set, I would see it here, and I'd be able to go across all of my machines within my application and map out what's where and make sure it landed, correctly. Real downside, if I didn't put this VM in an availability set, when I built it, it can never go in an availability set. It has to be rebuilt into an availability set. It's not like I can just right click, add to availability set. So just be very aware that as of today, you can't do that. Maybe tomorrow you can. We don't, there's been a lot of iteration since I started with Azure, but that's kind of that. Great. Any other questions around that?
I'm seeing none here in the chat. Tom, do we have any on Twitter?
No, Twitter's clear, but I was curious, as you're seeing people looking toward this and wanting to architect for availability and performance, how are you seeing them balance that? Are they going for more smaller instances, or do they have to design for one like zone but then duplicate that 10 times or whatever?
Yeah, really good question. It really comes down to how much availability does your application really need? And that really drives us as IT professionals to have to get into some business conversations and figure out, is my website, what's the amount of cost I lose for an hour, a minute of downtime, 5 minutes of downtime, whatever it is. And if that number is high enough, then we have to run the cost to figure out, great, I need 10 VMs to really do this well in one region, and I can't be down if an entire region goes out. So really, I need to duplicate this in US East and US West, or in a different country. If I need to go to Canada or something, I don't know. It all depends on what those requirements are. I know that's a little bit of a cheap answer, but it's really true. If a lot of the people I've worked with haven't had the need to go active, at least for like things like web servers in this way, right? There are other platform as a service offerings in Azure that I'm not going to talk about tonight that can do things like just bring your code or bring your containers and then we'll run it, and it's globally available. It's got SLAs around it, all that kind of stuff. So, but that's a little out of scope from what we're talking about. So yeah, it really is a cost justification of whether how available do you need it and at what tier and those kind of things. So yeah, I don't know if that fully answers the question.
Yep, thanks.
Yeah, great. So you guys watched me click through the portal, and that was really boring, and I don't think anyone really wants to watch me do that again. So let's do this in code. What if that's one of the huge things about Azure and really any hyperscaler, your AWS, Azure, or GCP, the ability to do this stuff in code and deploy it. And it's, we backed our way into it in the VMware world with VRE, VRO, but in the cloud world, that's where we started. And so let's do a couple quick demos and let's go from there. And then, we'll wrap this thing up. So ARM templates. You probably didn't notice when I deployed that VM, but at the bottom, there was an option to download the ARM template for that. So I can run right through the GUI, and at the end I can click and it generates the code that I need to build this machine again. So on the right here, I've got an example that I spun up earlier today. And so after running through and answering all my things, I went to download the code. I have the options for templates, CLI, PowerShell, Ruby, different ways of actually deploying this. And then I broke it out, and here I'm going to spin up 6 resources. So I'm going to spin up a network card, a network security group, a public IP address, a virtual network, the actual machine, and then a storage account where I'm going to hold all my diagnostics. And that's awesome because now I can download this and I can check it into source control so that next time I want to run it, A, I don't have to click through the GUI, and B, I can get it exactly the same way that I did the first time. Some really good places to go for these. So let's see if this will pop out. Perfect. If you go out to GitHub and check it out, there's Azure Quick Start templates. There are hundreds of templates that are publicly maintained for all kinds of stuff. And so let's and this is in the deck. So so the link's there, or you can just Google for Azure Quick Start templates. So if I want a simple Linux VM, there's a couple different things I can look through. I can either deploy it directly through Azure. I can click right here and it'll take this JSON and kick it right into Azure. I can visualize it, which is kind of cool. You can see your code and see the pieces. And I'll let you guys go play with that. But let's pop into this real quick and actually look at the code. So here is this is an Azure deploy JSON. Yes, it's in JSON. No, it's not YAML. It's not any other better language. But at the beginning, we've got our schema, we've got our parameters. So these are things that if I were to click that deploy in Azure, I would get drop-down menus that were defined with specific default values and allowed values. I've got different locations defined in strings. I've got some variables defined here. So things like VM size, VM name, public IP address, subnet that I wanted in, name of my NIC, name of my server, all that stuff right there, easy to update. And then I've got the actual resources. So the resources are the things that are going to get spun up in Azure. So I've got my type, Microsoft here, Microsoft.storage. This is my storage account. These are the variables. I can go right back to the variables and see that I'm pulling in that it's an LRS storage account. I didn't really get into all of that. There's, the storage accounts allow you to do locally redundant, geo-redundant, read-only. There's all these different options and more than I can get into tonight, but great, it's right there. The API version you're using, the SKUs, and any properties, and that's it. That gets deployed, and then the public IP address gets deployed, and then the network gets deployed, and the subnet. And I don't know if this template has it. Oh yeah, it totally does. Cool. So when this NIC gets spun up here, because we're defining Azure network, it's got these depends on, and so Azure ARM templates are not smart enough to know that by default you can't spin up a network interface card if your subnet or your virtual network doesn't exist or your public IP address isn't there. So these are where you define the resource that should already be in place when you run this. You don't have to code it in order, but you definitely have to get your depends on in order. That's a funny sentence I just said, depends on. Anyway, so yeah, so you have to get these right. But so it's a little bit rigid in that way, but now it's right here, and if I want to deploy it, I can just click the deploy, and I get it right. I can version control it. So I would highly recommend anyone that's starting into Azure, go check some of these out and see. There's a ton of different solutions that are deployed out here that are fairly decently maintained. And so if you're starting to play with your own stuff, it's a great place. It's open source, great place to pull other code, see how people spun up things like load balancers and all this other stuff. So when I was getting started, I spent a lot of time here. And then, yep, already showed. I did the Linux one, but this one shows a simple Windows one. So that's ARM templates. Let's do a Terraform demo, because ARM templates are great, but they're not declarative. I have to worry about things like, is my virtual network up yet? No, yes, maybe. Terraform is, and this is the last thing I'll do, and then we'll wrap up. Terraform is by HashiCorp, and it crosses a bunch of different providers. It's not just Azure, it's not just AWS, it's not just VMware. It crosses all kinds of places. And so we'll jump into this real quick. In the top right, we have this Cloud Shell, which is awesome, especially if it works. There he is. It's basically a shell directly into Azure for me, and I'm logged in. I'm in my subscription. I'm in my storage. I'm in my resource group, so it knows where I'm at. So great. There I am. I have PowerShell and I have Bash. For this demo, I'm going to use Bash, and my Cloud Shell actually does have a tiny storage account behind it, so my scripts and things like that are saved, and that's great. If there definitely some code you want to keep, like your Terraform code, I would keep it outside of it, but it's there if I need it. Yeah, it still is. Awesome. So let's CD into Terraform here, and I've got CD into resource group. Now this is cool. I didn't have to install anything, so I have Terraform init. So let's run the first command, Terraform init. What this is going to do is make sure that my shell is running a current version of Terraform and making sure that the plugins and the plugin provider is all good, right? I ran this earlier, so it's pretty quick, but validation succeeded. Terraform's built right into the Cloud Shell. So if you ever wanted to play with Terraform, really good place to start. I can right now start playing without having to worry about anything else. So let's do a quick vim on rg.tf. Now this isn't a full Terraform talk, so there's a lot around it. I'm just going to run through it kind of quickly because we're getting short on time here. But this is probably the world's most simple Terraform script. It literally just defines a single resource group. So this is one of the providers. It's an Azure RM provider. This is a Terraform thing. This is going to be my Terraform group. And then in my Terraform group, I'm going to spin up a resource group, and that resource group is going to be US East. Great, so let's do that real quick. Let's do that in not quit the shell. I will not have to init again. I just was doing that to show that, that it's there. I guess while that's loading up, any other questions?
I am not seeing any questions out there.
I never knew that the Terraform was built into this Cloud Shell thing. That's pretty amazing.
Yeah, sweet. There we go. Yeah, it's really nice. So CD to Terraform, CD resource group. All right, and let's do a Terraform plan. So what this is going to do is it's going to take a look at that. I'm in my resource group directory. I've defined that resource group, and it's going to go out and compare my current Azure setup to what I've defined. It's going to say, great. I need to put in location US East. I need to put this resource group. Is it there? No. In that case, there's one thing to add, and so I'm going to go ahead and do that. Play. Or sorry. Apply. I am crossing languages. And then just confirm it. And there it is. Done. So I didn't have a GUI to go run through. And just for funsies, I should see, there it is. Always on free, there it is. vBrownBag Terraform. And it's empty. So let's CD back real quick. And there's nothing in it. And come on. Okay, I have a VM Terraform script. This one is a little bit more intense, so let's just cat that real quick. And there's a ton of stuff defined in here. There's network security groups here. There's public IP addresses. There's a subnet. There's pretty much everything that you saw in my earlier resource group. It's all defined here. And Terraform is smart enough to figure out what needs to be spun up when. Passwords, SSH keys, all that stuff is right here. So same thing, same commands. We're going to go Terraform plan. So it'll take a little bit longer, and but should pop up and compare what was in. Now in this, I defined which resource group that I wanted it to target, which was the one I spun up already. And so you can see here everything it's going to do on the output, and you're going to see that we have 9 things to add. So let's just do Terraform apply, and this will take 2 minutes if it's still running the same way it ran earlier. So let's go ahead and just hit yes to confirm this, and boom, we're off and running. And it's going to begin to create stuff, and we'll begin to see stuff drop into my, there we go. already my public IP address and my network security group are up. And that was a lot easier than ARM. ARM is native, it's great, but I didn't have to define this depends on this. I just declared it in my opinion, a easier thing to view and read. And it's built in, I can play with it right in the shell. And so that's, for me, that's great. Bit word of warning, you would never do Terraform like I just did Terraform, because if I change something and then run it again, it's going to destroy what, or it has the power, let me caveat that, back off that statement. It has the power to destroy just as quickly as it creates, and it's vast and wide. So current state is stored in a file that I could show you in a few minutes after the stuff's done creating. Current state is stored in a text file, and so it's not actually reading initially it is to create that file, but if I have this massive file spun up, I need to keep those in sync. So just a word of warning, if you're actually gonna do Terraform in production, you should really have that in like some sort of a CI/CD pipeline, like to run this. So anyway, that is kind of the end of my demo. I don't want to take too much more time. Any questions while we're waiting for that to finish out?
So it looks like we've got a question on what is the use case for Terraform in Azure Cloud?
Yeah, so if, let's say, think about Terraform, one of the things that you could do is, while I didn't talk about it, you can capture images. You could take a 2016, Windows 2016 template. You could spin it up, tune what you wanted to, sys prep it, and then capture it like an image, just like you can with VMware and templates. And then I could deploy from that. And that'd be great, except for then I have to have that specific VM that is only in one resource, is only in one region. I have to cart that thing around. I have to update it myself and do all this stuff. Or I could build my template in code in like a Terraform and then use a PowerShell DSC or, a Chef to make sure it's what I want. I could just maintain those two files, and then I could say through code, Terraform apply, and it will spin out another VM, and I can hook Chef directly into that. It'll tune everything inside the OS like I want it. It'll join, I can then join to domain, all this other stuff, and I don't have to have an image. I can pull the latest Microsoft image and use that one every time. And so patching, stuff like that, I don't have to do, the dreaded, oh, I built this template 6 months ago and I'm gonna hit Windows updates and it's gonna take an hour and a half to patch before I can turn it over to you. I can shorten, so that's really, really nice. And I can, if there's large environments where I wanna make sure that, that this particular network security group gets applied, I can do that. If I do that in code, I know it happens every time. If I don't, maybe I spin it up and I forget to put the NSG on it, or pick the wrong one. There's a lot of options in Azure. Maybe I built an availability set and I forgot to put it in the availability set when I built it, and then the devs did their stuff and now it's ready for production, but I'm not in an availability set, so which means I have to destroy it and start over. There's some things to do there, but anyway, so those are just a few examples. So the big thing you should take away is, whether it's Terraform or ARM or any of the other ways, do your infrastructure in code, and it'll save you a bunch of time, especially when you're playing. If you're spinning a machine up and down, do it in code because it's way faster. The GUI, while quick, it gets a little cumbersome after you've played with it for a few weeks. You're like, okay, this was fun initially. Now I don't want to do this anymore. So that's probably my answer to it.
All right, I'm not seeing anything in our chat box. Tom, how's Twitter looking?
Looks clear over here.
Great, and here's our machine, all spun up. My VM, all up and ready. So great. Well, if there's no other questions, like I said, oh yeah, real quick. So I've got these resources on the back of this deck that if you guys want, just hit me up, and I can get it to you. Like I already said, Azure always free, air quotes, because some of it's like the first 12 months it's free. After that you have to pay. So kind of watch that. It's documented pretty clearly there. There's a couple of really good Linux Academy courses that I used for when I was prepping for my exams that I've taken. But these are really good if you have Linux Academy. Some good stuff on Pluralsight too. I've heard A Cloud Guru stuff really good. I have not used that yet. But these are really good. There's also a bunch of free training out there as well. So as you're getting started, definitely run through those if you got some time. And thanks. Please feel free to hit me up on Twitter or any other digital method. I'd love to answer any questions or just chat.
Excellent. Thank you. Thank you for your time. I certainly learned more about Azure than, I learned more today than I've known about Azure, so that's nice. Tom, any thoughts? Any closing thoughts here?
I think it's great that Azure has the automation Terraform and the Cloud Shell just built right in, so it's easy for someone to get started and figure out how to do it. Plus, we didn't go into this, but it gives you a script you can download every time you do anything through the GUI to let you configure what you did with command line. So Azure's really making it easy to learn how to DevOps.
Yeah. I tell you what, they've come a long way. I felt a little like, wow, I'm learning a Microsoft thing, which is a weird, which felt weird. They're the big corporate giant. I shouldn't want to jump into this, but man, they've done some really cool stuff. They've really made some huge strides in their platform, and they're really doing some really cool stuff for sure.
All right, then if that's it, I am going to go ahead and stop our recording. Give it just a second. No more questions, it looks like. All right, thank you, everybody.
Thanks, everyone.